Hi everyone, so this is a lesson on our second lesson on solving equations, and in this lesson we'll look at equations that require more than one step in order to solve them. So we'll first look, in fact before we do that, let's just remind ourselves what solving equations actually means. I'm just going to flick back to our notes from last lesson. Last lesson we wrote down that solving an equation means, well, it is the process you go through to find the single value that satisfies the equation or that makes it true. And we learnt about the balance method last lesson. So solving an equation is you're finding the single value, the single number that your unknown is equal to. And then the first equation we're going to look at is this one here. 4a plus 6 equals 16. So it's nice, low numbers and easy to work with. Now, if I look at this equation, I'm thinking, okay, well my unknown letter is this a, and when I'm solving I want to find what a actually is. But before we do that, we can kind of backtrack a few years back to when we were much younger and we learnt about number machines, probably in primary school, because we can express what's going on in this equation as a number machine. Okay, so remember when you were younger, you would have an input. Yes, I'll just write that. You'd have an input, and then you might do something, and then you'd get another number, and then you might do something else, and then you get your. In fact, I'll just write the word. You get your output. And you can have really complicated number machines that have more than two things happening. But we're just going to stick to two things for this one. And we can think about this equation as a number machine where our input is the letter A. And then, well, what's happening to A? And BidMaths helps us here. BidMaths helps us here because we can see we've got a plus 6 and we've got a multiplied by 4. But we know to follow when we follow BidMaths, the multiplication happens there. So A is being multiplied by 4, and then some other number, we'll get some other number, and then 6 is being added, and then we would get our output, which is 16. So we take A, we times it by 4, we add 6, and we get 16. So A is the input, and 16 is the output. And hopefully you remember that back from primary school, that if you have the output of a number machine, you can work backwards to get back to the input. So to get back to the input, maybe I'll switch my colours, we do inverse operations. So to go from 16 back to this kind of middle number that we don't know what it is right now, we do the inverse of add 6, so we would take away 6. And then from this number to get back to our input, we would do the inverse of multiply by 4, so we would actually divide by 4. So we're kind of undoing everything that has happened to our output in order to get back to our input. We are using inverse operations to undo what's happened here. Now, when you solve an equation, it's just an algebraic way of representing this number machine. You guys will be able to do this super easily. 16 take away 6, easy. Divided by 4, also easy. But when we can represent this algebraically, and that's when we use the balance method. So the first thing we did when we had our output is we had to subtract 6. Now the balance method tells us that you must do the same things to both sides of an equation. So I'm going to have to subtract 6 from both sides. From my output, 16 take away 6, that obviously leaves me with 10. And then on this side of the equation, well, the plus 6 minus 6 cancels and I'm left with 4a. So then, after we subtracted 6 from our output, we then had to divide by 4. So I'm going to show that as well, algebraically, like this. I'm going to divide by 4. So on the the left-hand side of my equal signs, we'll divide by 4 and times by 4 cancel, and we get back to our input. And 10 divided by 4 is 2.5. Or you can simplify that to 5 over 2. But that is essentially what we've done. And if you followed the steps on your number machine, you would get an input of 2.5. So everything we do in solving equations is just an algebraic representation of these kind of number machine problems that you would have done when you were much younger. We'll do another question with a number machine. So here I will use this example. So a over 4 plus 6 equals 16. So really similar question. So again, with this one, our input is a. Remember, we're always trying to find, when we're solving, we're trying to find a single numerical value. So a is our input. Now what has happened to a in this equation? Well, it hasn't been multiplied by 4 like this one. It's actually been divided by 4 to get something. And then 6 was added on. And that gave us our output of 16. So working backwards in our number machine, we first need to take off the 6. We need to do the inverse of plus 6. And then we need to do the inverse, or the opposite, of divide by 4, which is to multiply by 4. So these are the steps these are the steps we would do in our number machine, and you guys would be easily able to do that. But representing this algebraically is what we're learning to do. We're learning to solve our equations algebraically. So we first have to subtract 6, and remember in the balance method we do this to both sides of the equation. So here we take our output and take off 6, but we have to do it to both sides. So over here we get 10, and over here the plus 6 minus 6 cancel each other out, and we're left with a over 4. And then, looking back to our number machine, after we subtracted the 6, we then had to multiply by 4 to get back to our input. So we're going to do the same thing here. We're going to multiply by 4 on both sides, so that on the left-hand side we'll multiply by 4, divide by 4, cancel, and then 10 times by 4 is equal to 40. So this is the solution to the equation, but it's also, if we're talking about number machines, it's also the input that gives us an output of 16 for this particular number machine. Now obviously when you solve these types of equations in secondary school and in the future, you're not going to be drawing these number machines because they're time consuming. So I'm going to do 3 examples now without a number machine. So our first one is going to be, and I've plopped some negatives in here as well. So negative 35 equals 5x plus 20. So of course solving this equation means we're trying to find that value of x. We're trying to find what x is equal to, highlighting that letter. So instead of doing the number machine, what I would do is I look at x and I think, what's happening to x in this equation? And in what order? It's very important you think about the order. So first x is being multiplied by 5, and I just make a note of that here, and then 20 was added on. So this is what's happening to x in this equation. And then what I do is I draw an arrow like this, and I remind myself, okay, you need to work backwards, just like in our number machines. We work backwards from the output. We work backwards and we do the inverse operations. So I'm going to work backwards. So the inverse operation of add 20 is take away 20, and I should do that to both sides in the balance method, obviously, you do it to both sides. So on the right hand side, plus 20 minus 20 cancel, and we have 5x. And the left hand side, if you can't remember how to do negative 35 take away 20, you can use the change signs method here. Change the signs. So that gives us 35, 45, 65, and then you change the signs back. So we get negative 65 here. And then, so I've done that. And then my next step is I need to undo the multiply by 5. And to undo, I do the inverse, so I need to divide by 5 both sides. Like that. So on the right hand side, multiply by 5, divide by 5, cancel. And then negative 65 divided by 5 will be negative 13. And I have solved that equation. algebraically. And I haven't drawn a number machine. This is kind of like my secondary school number machine over here. Okay, the next one. I'm going to write a little bit smaller so I can fit all of this onto one page. So, second to last example, we have, where is it? Okay, we're going to have negative 6 equals c over 2 take away 4. So I first think to myself, okay, what am I trying to do? It's a little bit blurry. There we go. What am I trying to do? Well, I'm trying to find what c is equal to. So my answer should be c equals something, a number. Then I think to myself, okay, what's happening to c? And in what order? First, c is being divided by 2. Then 4 is subtracted. And I need to undo these working backwards. So that arrow going up shows me I'm working backwards. So first I need to undo take away 4. I need to do the inverse of take away 4, which is to add 4 to both sides. So that's going to give me negative 6 plus 4 is negative 2, and then c over 2 on the right hand side. So I've sorted out that, and now I need to undo divide by 2, and I'm going to do that by multiplying by 2 on both sides. So I'm going to get myself negative 4 over here, and then multiply by 2 and divide by 2 cancel to give me just c. So I found out that c is equal to negative 4, and I've solved the equation. So the last example we'll do, I'm just going to draw a line here, separate my work. So the last example we're going to do is this one. It is 1/5 x plus 26 equals 19. And I wanted to include this one because it has a fraction next to our letter x, which always throws people off, always throws students off. But we learnt last lesson that this can be written in this way, x over 5. In fact, I'm going to write it in my black pen. X over 5 is exactly the same as a fifth x. And when I write it like this just looks exactly the same as one of these questions, which are not too tricky. So what am I trying to do? Well, I'm trying to find what x is equal to, what number x is equal to, what is happening to x. It's being divided by 5, and then 26 is added on. And I must work backwards in order to solve and find what x is. So first I'm going to do the inverse of plus 26, which is to subtract 26. So on the left hand side of the equation, the add 26, subtract 26 cancel, and we have x over 5. And then I'm trying to do 19 take away 26, sorry. So 19 take away 26. I might use the change signs method, which gives me negative 19 plus 26. And then I might use the bubble method to switch the order of these and give me positive 26 take away 19. So that is the same as 26 if I take away 20 and add 1, 7. But remember I had to change signs earlier, so I have to change back. So negative 7 is the answer there. That's just a quick revision of what we did in negative numbers. So I have done the inverse of plus 26. Now I need to do the inverse of divide by 5, which is to multiply by 5 on both sides. So times by 5 divided by 5 cancel to give me x. And negative 7 multiplied by 5 is negative 35. And that is my answer.